dear students, how to perform stress concentration analysis on a square plate containing circular hole at the mid position of the square plate using ANSYS APDL software. Let us discuss in this lecture video. So we all know that stress will get concentrated at any specific portion of a structural member under loading condition if it has non-uniform stress distribution due to some irregularities in the geometry of the structural member. Okay, so it is measured by the parameter stress concentration factor. Stress concentration factor is denoted by the letter K, and it is the ratio between maximum stress and nominal stress. Okay. For the present case, nominal stress, sigma nominal, can be calculated using the regular stress induced formula, that is force per area. Since the considered square plate is consisting of a circular hole, the area can be calculated as the total width of the square plate minus the diameter of the circular into thickness. Okay, the maximum stress value can be taken from the FE analysis results. Okay, so let us discuss the procedure to solve this problem using ANSYS APDL page. So in this exercise, we are going to analyze the influence of the diameter of the circular hole on the stress concentration factor, okay, under the loading condition. So first select the type of the problem, that is structural problem. Go to preprocessor, select the type of element, that is solid element. Okay, go to options, select plane stress with thickness. Okay, go to real constants, add the element thickness is 10 mm, that is mentioned in the problem. Go to material properties, material models, structural, linear, elastic, isotropic. As the material of the considered square plate as steel, the Young's modulus of the steel is known to be 2×10⁵ Newton per mm square. Then we can model the square plate containing circular hole using areas option, rectangle by 2 corners. So the first corner is said to be the 0th position, that is a reference position. So 0, 0. Width and height of the rectangle is known to be 100 mm. Okay, then go to circle to create the circular portion at the mid of the generated square plate. So solid circle. So this is the center point of the circular portion to be generated. So that is 50, 50, because it is located at the mid position of the square plate. And first we are going to create a circular hole of diameter 10 mm. So the radius is 5 mm. Okay. So next to cut this circular portion to create a hole in the square plate, go to operate, booleans, subtract areas. Okay, so select the portion from which the circular portion to be cut. Okay, apply. Then select the portion to be cut. The first portion has been selected, so to select the circular portion, click next and OK. So now the portion has been cut from the entire plate, so the circular hole has been generated now. Okay, then go to meshing, mesh tool, lines set, click the edges of the modeled square plate. Okay, so split the sides, 10 subdivided elements, say. Okay, so now again go to mesh tool, mesh, select the entire portion, click OK. So all the edges have been subdivided into 10 elements. Okay, so there will be 11 nodal points at each edge. Okay, so now to define the constraints as well as loading conditions, go to define loads, apply structural displacement on lines, select the leftmost line, click OK. Since that portion is fixed, select all DOF and click OK. To define the loading condition, go to force or moment. So now we have created 11 nodal points at the right edge. So we can apply the loading condition at the nodal points on nodes. So click box option. So we can select all the 11 nodal points using the box option. Okay. So in the problem it is mentioned that the right portion has been subjected to 1000 Newton. So here there are 11 nodal points. So the 1000 Newton force can be distributed to all these 11 nodal points. So each nodal point will be experienced 1000 divided by 11, that is 90.91 Newton load in the x direction. Okay, so 90.91 Newton. Okay, so now we have defined the entire problem, so we can solve now using current load setup option. Solution is done. So to read the results, go to general post processor, plot results, contour plot, element solution, stress, x component of stress. Okay, so the maximum stress induced in the plate is 2.65938 megapascal. Okay, so for the first case, that is 10 mm diameter, maximum stress value is 2.65938 and the nominal stress value as load as 1000 Newton divided by width 100 mm minus diameter of the circular hole is 10 mm into thickness 10 mm. So 1000 divided by 90 into 10, the value is 1.1111 megapascal. So the stress concentration factor value for the first case is 2.3935. okay, so then we are going to increase the diameter of the circular hole from 10 to 20 mm. So for changing the diameter of the hole, in the answers page, go to session editor. So here the entire procedure we have followed will get programmed. So here, so the radius of the circular hole we have already fed for the first case is there 5 mm. So edit the radius of the circular hole for the second case as 10. Since we are going to create a circular hole of diameter 20 mm, radius as 10 mm, click save and OK. So now we can observe the stress plot for the second case, that is the stress, maximum stress induced in the square plate containing 20 mm diameter circular hole. Okay, the maximum stress value is 2.77647 2.77647 and the nominal stress value is 1000 divided by 100 minus 20 mm into thickness 10, so 1.25 Newton per mm square. So the stress concentration value will be 2.2212. Okay. Then for the third case, increase the diameter of the circular hole as 30 mm. So for that, again go to session editor, go to the radius data. So edit the radius as 15 mm. save, okay. So now we can get the maximum stress induced value for the diameter of 30 mm, 3.11513. Okay, so the nominal stress value is 1000 divided by 100 minus 30 into 10. So the value is 1.4286. So the stress concentration value is 2.18. Then for the fourth case, have the diameter value as 40 mm. So edit the radius value here, again change the value of 15 as 20, click save and OK. So this is the maximum stress value for the 40 mm diameter circular hole. So the maximum stress value is 3.5989. So the nominal stress value is 1000 divided by 100 minus 40 into 10. So the value is 1.6667. So the stress concentration factor for this case 3.5989 divided by 1.6667, 2.1593. Then for the fifth case, consider the diameter of the hole as 50 mm. So the nominal stress will be 1000 divided by 100 minus 50 into 100. The value is 2. So in answers page, edit the radius value as 25 mm. Save, OK. So the maximum stress induced value is 4.29785. The stress concentration factor value 2.1339. So from the analysis, it is palpable that the stress concentration factor will get decreased with the increase in the diameter of the circular hole. Okay. So if we plot the results in the graph, we will get a plot like this. So by increasing the diameter of the circular hole, the stress concentration factor will get reduced.